Okay, so welcome to the eighth live session. Today we'll be looking at assignment 9 rather than assignment 8 because I think your assignment 9 submission is close. It's probably on 29th or 30th of this month. So if we look at assignment 9 today, it will help you to solve the current assignment problems. And assignment 9 is mostly based on these dependent sources, the treatment with dependent sources. So the next assignment, probably assignment 10, is on two-port network theorems. So we'll be now looking at the current assignments one by one so that it helps you to solve the assignments of this semester. So let us start. I'll share my screen. Is my screen visible? Can you please confirm? Okay, okay, fine. Looking at assignment 9, and as I said before, this is the current assignment problem. So these are basically the dependent source problems, and I hope assignment 9 of this course also is on dependent sources. So this will actually help you solve the problems if you haven't submitted it yet. So let us start. uh, so this is the circuit for this problem, and they have told us to estimate the Thevenin voltage between terminals A and B. And so as we know, to calculate the Thevenin voltage between any two specified terminals, we need to open circuit that terminal and then find out what is the voltage across that terminal, right? So here there is a catch. See here, there are two dependent sources, right? One is the dependent current source and another is the dependent voltage source here, right? So here, for example, if this dependent source wasn't there, so if I just redraw the circuit here, let me just redraw the circuit without the dependent source. So this is the circuit without dependent source, right? And in the this diagram, they have clearly mentioned that the voltage across the resistor is nothing but V1, and this is terminal A and this is terminal B, right? So as a result, so this is 6 3 2V, and the current flowing through this is I1, this is V1 by 6, right? So if this dependent voltage source is not there, therefore you can easily write V1 equals to VTH, the Thevenin voltage across AB, terminal A and B. And why this VTH is equals to VT1? Because you are measuring the voltage across this 6 ohm resistor, nothing else, and this is equal to V1 only, and this is your Thevenin voltage. But instead, in this circuit here, we have this. Just let me use another ring. So instead here we have this thing, right? This there is a 9I dependent voltage source. Therefore, your VTH would now be equals to, so it won't be V1, right? Because there is a voltage source here. So it would be rather V1 minus 9I1. Why minus? Because the polarity of this V1 is this thing here at this. So if we consider the reference terminal to be grounded, so this is nothing but V1, the polarity is plus at the top and minus at the bottom, and this 9I voltage source is actually opposing this V1 voltage. Therefore this minus I comes here. Instead, if this would have been, if the dependent voltage terminal would have been minus here and plus, so then it would have been plus here, because V1, if you just calculate the voltage across this terminal, this would be adding up. The 9I would be adding up, provided this minus is here on the left hand side and this plus is here. But instead, as we can see, the plus is on this side, the left side, and the minus is on the right side, and it is opposing the V1 terminal, right? V1 voltage across the 6 ohm resistor. Therefore, this should be minus and not plus. Okay, so I'll just erase this. Uh, yes. So this is how we obtain the VTH for this circuit. Now we need to calculate what is V1 and I1. So I hope this is clear. Why this
Yes,
is
sir.
plus and not minus. Okay. So we'll try to solve this as quickly as possible. So now in this, now just concentrate on the initial circuit. So if we just ground this terminal, right, and we apply what you call the KCL across this node. So let us say this is node number 1. Okay. So what would be KCL at node 1? It would be, so here this I1 is flowing, and let me just use another ring here. So let us say, what is the pointer? Yeah, got it. So let us say that the current that is flowing through this node is, I mean through this wire, is I2, and this is I3. Okay, and there won't be any current flowing through this because this is open, right? So this, therefore your I4 would be 0. I hope this is, I mean this you can easily understand, because this is open, therefore I4 would be 0. Therefore if we apply KCL at this node, this would be I2 plus I3, right? So let us keep I1 as it is. And what would be I2? I2 is your V1 by 6, right? So just don't get confused by this ohm sign, okay? You don't have to take into account. They have just written, because this is a, see, this is a current source, right? So V1 by 6 amperes. So current, right? Voltage by resistance is equal to current, right? Ohm's law. So therefore in the denominator they have written this ohm sign. Similarly in this voltage source also, it's current into your resistance, right? So therefore I is the current and 9 ohm is the resistor. So it's actually 9I, and this is V1 by 6, nothing else, right? And what is, so what is your, so this would be V1 by 6. And similarly here also, this is node voltage. So here this node and this node, the voltage is equal, right? So this would also be equal to V1 by 6. So therefore your I1 is V1 by 3. Now what is actually I1? So it is nothing but the current flowing between 2 volt and this node 1, right? So if we just apply KCL here, so this is 2 minus V1 by 3, right? Simple. Therefore if we just substitute this I here, it would be 2 minus V1 by 3 equals to V1 by 3. Therefore this gets cancelled, and this becomes equals to 2V1 equals to 2. Therefore V1 equals to 1 volt. And your so you have got your V1. So now if you look at this equation, right, our initial equation, so actual, so it would be 2 minus 3 minus 1 by 3, it is 1 by 3 ampere, right? Therefore um, your I1, no, we have got I1, so VTH would be what? VTH would be V1, which is 1 volt, right? And this is 9I1, right? So hence this would be, this is 3. So this is how you calculate VTH. It is pretty simple, provided you know what is VTH actually. So this is V1 minus 9I1. And once you do that, you simply apply KCL at this node 1. You obtain what is I and V1 in terms of I1, and you calculate I1. That after that, you will get your final answer. So I hope this is clear.
Clear, sir.
Okay. When is your exam? Final exam?
30 April.
14th April.
30.
Okay, 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 fine. Yeah. So next, move on to the next question. Now they are saying estimate the short circuit current between terminals A and B in the direction A to B. Why this is mentioned? This is important, right? In the direction A to B, we'll see this because they would have could have also mentioned in the direction B to A. So, as we know, in Norton's theorem, we need to short circuit the terminal, right? So, this is terminal AB, therefore, we need to short circuit the terminal. So, quickly let us redraw the circuit. So, this was your terminal AB, right? And now in Norton's theorem, we need to short this. So, hence we have shorted this. And now they are telling us to find out what is the short circuit current from A to B, right? So, therefore, we shall write this as this. So, that direction would be from A to B downwards, not B to A. They have clearly mentioned this. Otherwise, your ISC would come in minus, nothing else. So, this is 2 volt, and this is 3. This is V1 by 6. This is 6, and this is 9I1, right? So, and this is obviously I here, and this voltage is also V1. So, see here, since we are shorting ISC, this V1 won't be equals to 0. Okay. Why? Because you have a dependent voltage source here, which is controlling the current through this AB terminal if you short it, right? So therefore your 6 ohm resistor can't you can't cancel off this. You can't do that because there would be a current flowing through this. Why? Because there is a voltage source here. So therefore your V1 can't be equal to 0. Now, so after this, we can easily again use the KCL here. So let this be I2 and let this be I3. Okay. So here this would be I1 equals to V1 by 6 plus again V1 by 6, right? Because this is the current, so this is also V1 by 6, and that voltage at this node is V1, and we have shorted this using KCL like the previous one problem. So this would be V1 by 3, right?
Yes,
Yeah,
sir.
and also I did a mistake. There would be ISC here, right? Because see, basically this I1 is getting divided into three parts, right? This through this wire. So this is I1 through this, and also this thing, right? So through the 9 I1 voltage source. So this is also there. So therefore there would be ISC. I hope you understand this, because there is this current source I2, right? There is this resistance of 6 ohm, and there is also this path, right? So previously in this problem there was no current, right? Because this was open, but now this is actually shorted, right? So where the current flowing through this path is ISC. Therefore, this would be ISC. I hope this is clear. Okay, so now see, we can't actually, so we need to get another equation, right? Previously, what we did, we were, so we only got, so it's, previously this ISC was 0 because AB terminal was open. Now, and we also got this equation, but now see, here if I write I1 equals to 2 minus V1 by 3, and if I substitute this here, so I will get 2 V1 by 3, 2 minus V1 by 3 equals to V1 by 3 plus ISC, right? So we can't actually solve this because we don't know ISC, we don't know V1, right? So what we can do here, see, uh, we know that this terminal is grounded and this terminal is V1. So what would be, so if I just take this path, let me just use another ink here, probably red. So if I take this path, okay, this path, so what is the voltage, how is V1 and V0? So your ground voltage, basically the reference node voltage related. So this is actually related by this dependent source voltage, right? Because this is present between V1 and 0 through this AB path, right? So therefore, what would be V1 minus V0? It would be 9I1, okay? Because this is actually connected between A and B, basically between 1 and reference voltage, and your V0 is 0. Why? Because you have grounded it. Therefore V1 would be nothing but 9I1. I hope you have understood this, how, why this equation was written. If not, please tell me, I'll explain it again.
Got it.
Okay. Okay, so this is 3ISC, and now we have actually got a equation, right? So we can actually substitute this here. So let us call this equation 1, equation 2, and equation 3. Okay, so let's delete this. Substituting equation 3 in 1. Now this would be what? I1 equals to 9I1 minus 3 by 3. So this would be 3I1 plus 9I1 equals to 12, 2. So therefore I1 would be 2 by 12 ampere, therefore 1 by 6 ampere. Now what would be V1? Your V1 would be 9 by 6 I1, basically 9 I1, so 9 by 6 volt, therefore 3 by 2 volts. Now you can substitute, so substituting V1 in equation, equation um, what, 2, right? So once you do that, so basically this would be what, so if I just simplify this further, 2 equals to 2v1 plus 3 isc, right? So this is our equation number 2. Therefore, this would be what, 2 into 3 by 2 plus 3 isc, right? So this gets cancelled. Therefore, isc is 1 by 3 ampere. Okay. So this is, or rather, mm, minus 0.33 amperes. Okay. So this is what they told you to find out. What is the direction of current, short circuit current from A to B, and also the, of course, the magnitude. So this is nothing but minus 0.33 amperes. Okay. So this is your final answer. I hope this was understandable.
Yes, got it.
Okay. So now next the last question of this problem. So they have told us what is the Thevenin resistance between terminals A and B. So similar problem we saw in last week's assignment also. In order C, so for calculating the Thevenin resistance of this dependent circuit, dependent current or voltage source circuits, you simply can't, so if you just short this, so what we know for calculating RTH, you need to short circuit voltage sources and replace them by their internal impedance, and also open circuit your current sources, right? So current sources, or CS rather. Now this is only possible when you have dependent sources, right? This is only possible when you have independent sources. This is only possible when you have independent sources, but now in this circuit you have dependent sources. You just can't short them or open them, because this is actually dependent on, so for example this I1, it is dependent on the current that is flowing through 3 amperes, 3 ohm source, resistor. This voltage is, V1 is the voltage across the 6 ohm resistor, so you can't short this or open a current source, dependent current source. So in this kind of cases, what you do, so when you have, so for problems or circuits having dependent sources, what you do, you calculate ISC, that is Norton's current or a short circuit current, you calculate Thevenin voltage, and then your Thevenin resistance would be nothing but VTH by ISC in case of dependent sources. So this is what should be your methodology. Therefore, for this problem also, since this is dependent sources, so we will be calculating the Thevenin voltage in the same way. Therefore, VTH is what? VTH is minus 2 volts, and your short circuit current is minus 1 by 3, we just calculated, right? So therefore this would be 6 ohms. This minus minus gets cancelled. So therefore use 80H is 6 ohms. So this is how you calculate your Thevenin resistance when you have a dependent circuit. And see, this will work provided you short, or I mean, if you are told to calculate the Thevenin resistance across terminal A and B, right? So across these two terminals, then you need to calculate the Thevenin voltage across terminal A and B, and also the Norton short circuit current across terminal A and B. I mean, both these two terminals should match. Then only you will be able to divide VTH. I mean, do VTH by ISC, and finally get the RTH. This should be the methodology for calculating Thevenin resistance. So I hope this was clear. Pretty simple problem provided you know the steps. If you have any doubt, you can ask anytime.
No doubt, sir.
Okay. So let us move to the next problem. Just let me pull it up. A lot of space. Okay. So this is a circuit that is given to us. Simple small circuit, and here you see that um, we don't know what is the value of R1. We don't know what is the value of R2, right? We know what is the source voltage, and just let me use another ink here. Yeah. So let us consider that the current flowing through this path is I1. Now this gets divided into two parts. This is I2, and since this is point 0.7 is pointing upwards, I am also doing like this. Okay. So here you can easily use I1 plus I3 equals to I2, provided we ground this, right? So here you see that your R1 resistance, it's not given, right? R1 is not given, R2 is not given, and I is, of course, you need to find out, right? I, you need to find out. On the other hand, you know what is the value of I2. Clearly you can see this, because why? Your I2, it is clearly given 34 amperes, right? And there is a current flowing through R2. Therefore I2 is 34 amperes. Now once you know this, once you note all of these values, your problem will be quickly solved. So what is I1? I1 is nothing but I, and what is I3? I3 is nothing but 0.79, right? So if we just replace the values in this equation, I plus zero point 0.7 I is equal to 34. So therefore this is 1.7 I, and this is equal to 34. So therefore your this thing would be, so 34 by 1.7 is 20 amperes. Therefore this is the answer to the first question. I hope this is clear. Pretty simple. I mean, for if you are provided with these values, you don't need the resistance values. Okay, so this makes the analysis calculation much easier and quicker. I hope this is clear.
Yes, sir.
Okay, so now just let us solve the next part. Let me just pull it upwards. Okay, so now they have told us what is the power supplied by the independent source. So independent source is 15 volts here. So uh, independent source is the 15-volt source, voltage source, right? So therefore the power that it would be supplying is nothing but your 15, its voltage value times the I value, the current that is flowing through it. So this is nothing but 59, right? So therefore power supplied by the 15-volt source is nothing but 15 times I, and we just now calculated what is the value of I here. That is nothing but 15 into 20 watt. So this is 300 watt. So this is the answer to the first, your fifth question. A pretty simple problem. I hope this is clear. Let us quickly now move on to the next question. Just pull it upwards because there's a lot of open space. Okay. Now, here you see in this circuit, they have told us what is the value of I1. So there are two things, right? I1 and I2. So question 6 is about finding I1, question 7 is about finding I2, right? So here you see there are two, there is actually one independent dependent source and two independent sources, right? And this is again, you don't need to consider this ohm part because this is volt resistance into current, therefore this 20I simple. So here we need to calculate what is the value of I1. Now, clearly you can see there are a lot of resistors here, right? So it would be really complex to apply KCL, and also there is a resistance bottom. So if you ground this, I mean, this would make the analysis more complex, which I feel you can use KCL, of course, but here let us use KVL. So there would be two mesh 1 and mesh 2, right? So let me just uh, use a different thing to highlight the current. Okay. So in this mesh, let us consider like this. So this, let us consider that the current that is flowing through this is I1, and this would be equal to capital I1 only. Why? Because you see that through this path I1 is only flowing. Therefore, we can write it as I1. Similarly, here also this is I2, and the direction of current I1 and I2 are opposite because you can clearly see I1 is flowing in anti-clockwise direction, right? And I2 is flowing in anti-clockwise and I1 is flowing in clockwise direction. Therefore, this would be the direction of current. Now we can start solving. So let us solve the first mesh, right? So this would be what, 20 minus 20 I2, right? Which would be equal to your 30 I1 plus 20 I1, and again the direction of current I1 and I2 both are same, looking at the 20 ohm, right? So because you see I1 is also entering 20 I1 and from the top part, and I2 is also entering 20, right? So therefore this would also be plus and not minus. So this would be what, 20 equals to, this would be 50 I1, this would go to this side, this would be 40 I2. So this would be 2 equals to 5 I1 plus 4 I2. And let us take this as our first equation. Um, Now we are left with a second mesh, right? So let us apply KVL here also. This would be what, 15 equals to 20 I2 plus 20 I2, again plus 20 I1, right? Therefore this would be what, 15 equals to 40 I2 plus 20 I1. Therefore if you just cancel, take 5 common from both sides, this would be 8 I2 plus 4 I1. Okay, so now simple, we just need to solve these two equations. So let us see here, this, there is 4 I2 here, there is 8 I2 here. So we can do like this, 1 into 2 minus 1, 2 into 1. So we will be cancelling I2 from both sides. Okay, so this would be 2 into 2 minus 3 into 1 equals to 5 I1 into 2 plus 4 I2 into 2 minus 8 I2 minus 4 I1. Right, so this thing and this thing will get cancelled, and this would be what, 4 minus 3 goes to 10 I1 minus 4 I1. Therefore this would be 6 I1, and therefore your I1 would be 1 by 6 amperes, which would be point, what is 1 by 6? It's around 1.667 amperes. So this would be the answer to your first question. calculate I1. So I hope this is clear. Simple problem. Okay. So let us quickly solve the second part also. Let me take it up. Yeah. So what would be I2? So we just need to replace I1 in one of the equations. So let us replace it in the first equation. Therefore, your this would be 2 equals to 5 I1. So I1 was 1 by 6. Therefore, 5 by 6 plus 4 I2, I think. Yeah, 4 I2. So this would be 12 minus 5 by 6 equals to 4 I2. I2 would be 7 by 24 amperes. Could you tell me what is the value of 7 by 24 if you are still there? Hello. Okay, so let me just calculate myself. Mm, this is what this is 0.29167 amperes. So yeah, so this is how you calculate I1 and I2. I hope this is clear. So now let us solve the last part. So this has 4 questions and this circuit is pretty complex. Let me just pull it upwards. Hmm. Okay, so let us solve the last part and after that we'll quickly wrap up today. We won't solve any extra questions. Okay, so we are given this circuit and they have told us to find out what is the power supplied by the independent source. So here clearly you can see in this circuit we have one independent source of 6 volt and there are two dependent sources. This is this current source and this voltage source, right? And this is 8 sigma, right? Ohm inverse. Why 8 ohm inverse? Because this is voltage by current, right? Uh, Sorry, voltage by resistance, and inverse of resistance is conductance, which is sigma, right? So therefore this is 8 ohm inverse. Okay, and this is again, this we have already uh, seen previously. So they are telling us to find out the power supplied or generated by the 6 volt source. So therefore, mm, let us now mark each of the nodes here. So this is our node 1, this is node 2, and let us ground this node. Okay, so therefore if I just use another ink here, so this is I1 here and it's already marked, right? So I'm not using any other thing, but yeah, so you can clearly see V1 is what, 6 volts, right? Because is the V1 is the voltage across the independent source. And what is V2? V2, it is nothing but the voltage of 6 volts applied across the 10 ohm resistor, because there is no resistance in this path, therefore this total voltage, I mean there would be no voltage drop, right? Therefore this total 6 volts would be applied across V2. Therefore your V2 would also be equals to 6 volts. And it is, I mean, before starting the problem, it's very important that you identify these things, okay? And okay, fine. Now, what would be I3? I3 is the current flowing between nodes 1 and 2, which is nothing but 8V1. Therefore, your I3 is nothing but 8V1. Okay. And what would be V2? V2 would be nothing but V4, right? Because so sorry, let us not instead use these things, not 1 and 2. Instead, we can use A and B because these would be confusing. We already have a 2 here. This would be confusing. So let us just use A and B. So this would be A and this would be B. Okay. So instead, this would be VB, right? This would be VB and VB would be equals to V4, right? Which is nothing but equals to 8I2. Why? Because there is no resistance applied, right? So therefore VB would be equals to V4, which is equals to 8I2. So once you have written this, you can easily now start solving the problems because it's important to identify what is the values of each of the parameters, right? So therefore, let us apply KCL at node A, right? So let me just pull it downwards and write this. Applying KCL at node A. So this would be what? Um, this would be I1. I'm sorry. So this would be I1. Therefore, I1 equals to I2 plus I3, right? So, what is your I2? I2 is nothing but V2 by 10. We already saw it, and I3 is nothing but 8V1. Now, V2 is what? 6 volts, therefore 6 by 10, and V1 is also 6 volts, therefore 6 by 6 into 8. This is amperes, right? So easily you see you are able to find out what is the value of I1. Therefore, this is 6 by 10 and 48. Therefore, this is what 6 plus 480 by 10 amps or 48.6 amperes. And therefore, they are telling us to find out what is the electrical power supplied or generated by the independent. So, therefore, this would be V1 into I1, nothing else. Therefore, power supplied by independent currents, voltage source. This would be V1 into I1. Therefore, 6 into 48.6 watt. This would be around, um, yeah, this would be around 291.6 watt, which is the answer to your first question. So, I hope this was clear. Basically, for this problem, this is a simple problem, but lot of parameters are given. That is why you need to highlight all of these parameters first, and once you do that, you will see the analysis would become very simple. I hope this is clear.
Yes, sir, clear.
Okay, now let us solve the next part, which is actually quite downwards. So let me just bring it upward. So I leave a lot of space so that you know there is no shortage of space. But here it seems that there is a lot of space. I need to pull it upwards. Okay. So now they are telling us what is the power supplied or generated by the current source, right? Current source, which is I3 or I mean 8V1, right? So first let us write the equation. So power supplied by dependent current source would be what. See, it is nothing but the potential drop or the voltage difference between terminals A and B multiplied this current by this current source. So it's nothing but VA minus VB into 8V1. Sorry, 8V1. So this is nothing but this potential minus this potential at VA minus VB would give us the potential difference between these two nodes, right, in this path multiplied by the current source, right, which is 8V1. Simple. So now we need to just calculate what is VA and VB, right? So VB is nothing but 8I2. So we saw it earlier. VB is nothing but 8I2 or V4 rather, 8I2, and your VA is nothing but 6 volts. So VA, it is V2 is equals to VA only. So it's nothing but 6 volts. So what would be I2? I2 is nothing but, see, I2 we found out it's nothing but 6 by 10 amperes. Right? We saw here, we found out. Yes, this is I2. So I2 was V2 by 10 where V is 6. So therefore I2 is 6 by 10. So once you do that, you can easily see you are able to get all the values. So VB is nothing but 8 into 6 by 10. So for 4.8, sorry, this would be volts. So this is 4.8 volts. Now your power, so let us denote it as P2. So P2 would be 6 minus 4.8 into 8 into 6 because V1 is 6, right? So therefore this would be what, 1.2 into 48 watts, which would be nothing but, so what would be the value, 48 into 1.2, it is 57.6 watts. So this is the power which is being delivered or I mean supplied by the dependent current source. Okay, so I hope this part is clear. Simple problem, but lot of parameters actually. Let us go to the next part. And we have only two questions remaining. Okay. So now they are telling what is the power supplied by the generated by the dependent voltage source. So dependent voltage source is V4, right? And the power generated by this source is nothing but V4 into I4, the current that it is generating, right? So, um, so power supplied by the dependent voltage source would be nothing but V4 into minus I4. Why minus? See, because I mean, since it is generating, right? So the current would be flowing outwards, right? Not inwards. So I4 is actually flowing downwards. But if V4 is generating, therefore it would be flowing outwards, right? Simple. That is why this minus. I mean, if it would have been V4 into I4 and not minus I4, then it would have been absorbing the power, right? Instead, they have told us that what is the power that it is generating or supplying. So therefore, this minus sign is there. I hope this is clear.
Yes, sir.
Okay. So V4 is what we V4 is VB only, right? V4 is VB, and I4 is what? Hmm. Okay. So we now here we need to calculate. We need to solve this node basically, right? So let us do that. I'll just remove this. So here you see I3 is getting divided into two parts. So I3 is equal to I4 plus I5, right? Um, so solving node 2 now. So this would be equal to what? I3 would be equal to I4 plus I5, and I3 is what? 8V1, right? So I3 is 8V1 and I4, uh, let us keep it I4 only because there is no resistor here. And I5 is what? It's VB by this resistance, right? So V5 is also, your V5 is also equals to VB. Okay, it's simple because this the same voltage is applied across this 5 ohm resistor also. So this is equals to um, your VB by 5, right? So now we know what is V1 and VB, right? We just calculated it. So this is V1 is 6, right? So this thing, and this is what um, VB is 4.8, right? 4.8 divided by 5. Therefore, if you now calculate this, mm, wait, I might have made a mistake. Just a minute. Okay, V4 is also VB, right? Yeah, V4 is also VB. I'm sorry for the delay. So V4 is also VB because this is the same terminal. I mean, there is no resistance in this path, right? So V4 is directly equals to VB, right? So we don't actually need to solve this anymore. So V4 is also VB, which is equals to what? It is equals to VB was 4.8 only volts, and therefore I4 would be what? Uh, just a minute. Yeah, now we need to solve for I4. Yes. We needed the value of V4. Okay. So I3 is what? 8 V1, and I4 we don't know, and I5 is what? I5 is VB by 5 or V5 by 5, whatever you may write. So this is VB by 5, and VB was initially was how much? It was 48.6, right? So 48.6 is 24 by 5. I mean, if I just calculate it. Mm. So this is 8 by 6 I4, and this is 24 by 5 by 5. So this is 48 minus 24 by 25 I4. Okay. So this would be what? 48 minus 24 by 25 is 47.04 amperes. Okay. So once you do that, you can easily now calculate it. You know V4 it's equals to VB only. Therefore, if I write it as P3, this power, so P3 would be equals to minus of 4.8, which is 24 by 5 into 47.04 watt. So this would come around to minus 225.792 watts. So this is the answer to the second last question, question number 10. I hope this is clear. I mean, there was some confusion in this, but I mean, this because we didn't know what is the value of V4 and I4, so we had to calculate this, right? V4 is equals to VB only. By looking at the circuit, you can easily see that this is nothing but V4 and V5 is also VB, and you need to calculate I5 and I4, which we did by solving the second node equation, right? And after this, it's pretty simple. You just calculate minus V4 into I4. And why minus? Because the current is actually flowing into V4, right? But if it is generating, so current should actually flow out of V4, right? So therefore, this minus, it's minus V4 into I4, which gives us minus 225.792 watts. Okay, I hope this is clear. So we'll quickly go to the last question and we'll wrap up today's session. I'm really sorry for this thing. Okay, so next they are telling estimate the electrical power consumed dissipated by the two resistors. So two resistors means 10 ohm and 5 ohm resistor. Now see, let us calculate one by one what is the power dissipated across the 10 ohm resistor. So it would be nothing but I2 square into R, Joule's heating effect. So I square R. So therefore the current that is flowing through this 10 ohm resistor is I2. Therefore the power that it dissipates is I2 square into R. So therefore power dissipated by 10 ohm resistor is what I2 square into 10, and I2 we already calculated. So it was how much? Mm, yeah, it's 6 by 10, right? So this would be what? 6 by 10 square into 10. So this would be what? 48 by 100 into 10 is 48 by 10 watts, so 4.8 watts. Okay. Now we have another resistor, the last one. So its power dissipation would be I square 5 into 5 because I5 is flowing through the 5 ohm resistor. Therefore, uh, power dissipated by 5 ohm resistor would be I5 square into 5. So now I5 is how much? It was probably 24 by 25, right? Yeah, it's 24 by 25. So this was I that VB by 5, which was 24 by 5. So this thing, right? So 24 by 25 ampere. Therefore, this would be 24 by 25 whole square into 5 watt. So this would be what 24 square by 25 square into 5. So this 5 just gets cancelled. and this would come out to be mm, oh sorry, this is wrong, right? 6 into 6 is 36, it's not 48. I'm sorry. This would be 36 by 100 into 10. So this would be 3.6 watts, and this would be mm, 4.608 watt. Now they have told us to estimate the power dissipated by the two resistors, right? So you have to put a single answer. So if this is P10, P10 is denoted by the 10 ohm resistor and P5. Therefore, your P dot would be P10 plus P5. Okay. So this would be 3.6 plus 4.608 watt. Therefore, this would be how much? This would be 8 point. Uh, this would be how much? 2. Yeah, 208. So this is your answer. Why I am adding it? Because they have clearly told to estimate the electrical power consumed by the two resistors. So you need to calculate the total power which is being dissipated by the in the two resistors. So this is how you solve this problem. This set question number 8 to 11 was a bit lengthy, but I mean for this you need to highlight all of these parameters first, and then the analysis becomes pretty simple later afterwards. Okay. So this was all about assignment 9. We have finished quickly today. We won't be
Yes,
solving
sir.
any extra questions. So next week we'll be looking at assignment 10, which is your two-port theory, two-port problems. Okay. So if you have any doubt, you can ask. Otherwise, we'll close the session today.
No doubt, sir.
Okay. Fine. Chalo then. We'll meet next week. Thank you.
Thank you, sir. Good night.
Good night.